This is part 2 of the series working on using a RSLogix 1400 or a non-microstarter Lite controller with the emulator. As a matter of fact, using any controller other than the 1000 and the 1100, and then using the emulator offline. Actually, using any RSLogix controller, hands-on hardware, and then going back and forth using the RSLogix Emulate500 in another location with all free software. And what I've done is I've created a template, a program, a set of files with some code that allows you to do some really clever things in the emulator where you don't have as much stress toggling stuff on and off. Typically with the emulator, if you want to turn an input on and you want it momentary, you have to right click toggle bit and then right click toggle bit. You have to toggle it twice to go from off to on and back to off. I wrote code that allows you to just toggle on it and treat it as a normally open, normally closed, or maintained, or combination of things in your code. So let's look at these program files and how you use them. So the first thing you're going to do if you're going to use this template. Now I created this project and I saved it as ML1100 EMU template, meaning that it's a template for a RSLogix 1100 in an emulator. So if you're going to use this, once you've got your code in, you need to save it with a name that includes something that lets you know not to open this up and change it. To open it up, save as, and then start changing it. That way you can always go back to this program. First thing you need to notice is that I created 4 new ladder files over here. Ladder file 3, 253, 254, and 255. We know that we can expand the program files out to 255, or a total of 256 if you count system 0, system 1, ladder 2, ladder 3, and so on. And you don't have to have a 3 to have a 4 to have a 5. I picked the last 3 or the highest 3 numbers to get them clear out of the way of any programming that you would do. You're going to do all of your programming in the main, ladder 3, and if you're going to create subroutines, besides the ones you see right here, there'll be 4, 5, and up, and the JSRs will be in the main program in ladder 3. So all of your programming, when you use this template, is going to be in ladder 3, and consequently in 4, 5, 6, 7, 8, and up, and so forth. But you won't touch ladder 2 or 253, 254, and 255. That all works in the background to give you the benefit that you need. Now, I do have a bit here that I can toggle on and off if I'm running this right now, say in a RSLogix 1400, a real controller, or any real RSLogix controller. I want that bit off because these 2 files right here, the code in there, will totally screw up what you're doing in a real controller. But we're going to do an emulator, so I'm going to toggle this bit on. And right now I am downloaded in the emulator. I'm running the emulator right now, not the 1400. If you go to controller properties, see there, RSLogix 1100 Series B. Okay, so you need to create, right click on program files and then create 3, 253, 254, 255, name them according. Now I'm going to show you that in ladder 2, you're looking right here, you've got these 4 JSRs that go to these 4 ladder files. But these 2, 254 and 255, are only going to get executed if you're in the emulator for the 1100. Okay, so now I'm going to go to main and show you there's nothing there. Go to HMI, and now you're looking at a screen that basically shows you the state of 10 inputs and 6 outputs. And this was probably originally written with an actual 1100, but keep in mind the 1100 does not have as many I/O as the 1400. So this is what you've got to work with, including if you go back and forth to a 1400 or a larger controller, a real hardware one, you're still limited with how much I/O you can have in the 1100. Just keep that in mind. So you're probably wondering, well, why is input 2 on right now? Because remember, I have no I/O. Well, if we go back to setup, input 2 right here was set up as a normally closed push button. Input 1 is a normally open, and input 0 is a maintain. So if I go back here to HMI, and if this is set up as a normally closed, what would happen if I toggle that bit? So I'm going to right click, toggle bit, and 1 second later it comes right back on. So that code in ladder 255 executes against all of these inputs based on how you configured them. Maintain, normally open, normally closed. So a maintain, if I right click on that toggle bit, you would expect it to come on and stay on, correct? It's on, it's on, it's on. And then if I go toggle it again, it goes off. So it's a maintained selector switch. This is a normally open. If I toggle this on and then wait 1 second, it goes back off. So it's a normally open. You toggle it, and it acts like a 1 second momentary contact from your finger. So what this does is this allows you to write logic. And because you don't have any field devices, you don't have a field device simulator, you don't have lights and switches, you have everything with the mouse clicks. But this way, when you click on one of these inputs, it's going to behave exactly the way you configured it. Now, I only configured 0, 1, and 2. Watch what happens with 3. I'll right click on it. You see it flash, but it really never went on, not truly. Okay, and the reason is because we have code in here. If I go down to input 3, see, it's not configured as anything. So there is nothing to execute. So I toggle it on and it goes right back off, just like it would real I/O in a controller. So these files are here to help you. So if you're going to do this yourself, create these extra files. These don't have to be 253, 254, 255. You can make anything you want. I'm just trying to make this neat and tidy. So you create 4 new files named main, HMI, setup, and inputs. Okay, so you can pause right now and go do that, and then come back when you're ready to put some of the other code in. So there's nothing in the main program. If I go to HMI, you pause here and put in this code. Now the setup, I'll unconfigure these right here just to make everything neat and tidy. And then go back to HMI, and you see they're all off. So you just need to create a couple rungs, one that show the state of the input and the other that shows the state of the output. And as you move on in your programming experience, in the manuals, that's the orange and black set of manuals from PLC University, PLC Professor, you can actually add more HMI type content onto this screen. So let's say you've got a sequence with 7 steps in it, and you've used B3, 1 through 7. You can label them as step 1, step 2, step 3, step 4, 5, 6, and 7, and look at them right here. You can see it going through the steps. So this is your HMI screen because you really don't have one, but this is kind of a poor man's HMI. So pause right here, put these 2 rungs in, and then come back when you got them done. So at this point, you should have these 5 ladder files, and in ladder 2, you should have these 4 rungs that have JSRs to these files, and then you have a common bit, true if on, for both of these, so you can toggle on and off this logic right here that simulates your buttons. Okay, so this is what you should have in ladder 2. If you want, pause right here, create this logic, and then come back. HMI, you've got that done. Now we go to setup, which is a few more rungs, so you can pause, put this code in, and then come back and keep moving. So this, if I was doing this, I would create 1 rung and then copy, paste, 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 paste. And then go in and edit the memory locations, because all these memory locations are different here. Now this one isn't. Remember, this is just a placeholder. This is a no-op. It unlatches bit B320, but there's nothing turning it on. So you're not really doing anything. It just is a placeholder at the end of the rung so you can do what we're doing right here and make it look neat. So once you've got this done, it's done. You never have to come back and troubleshoot this. So pause, put all this code in. It's going to take a few minutes, but take your time and make sure you got it right. At this point, you've got all your code in except for the input file. Now this one is bigger. This is a bigger file. So you're looking at 4 rungs of logic right here, and you need these 4 rungs for each of the 10 inputs. The first 3 facilitate you being able to select the configuration for input 0 as a maintain, normally open, or normally close. All this logic does is if you select one, it unselects the others. So you cannot accidentally set up one input for more than one type of function. That's all these 3 rungs do. I know this is a lot of typing. It's going to take you a while to do this, but you'll be tickled with the result down the road. Then the 4th rung basically facilitates the behavior that if you toggle on input 0, it toggles itself back off if it's a normally open up here. Okay, so here normally close, so and maintain. So this is the logic right here that actually gives you the behavior of maintained or normally closed and normally open. And the 1 second there, that simulates you pressing and releasing the button in 1 second. If you want a longer pause, like you push the button and hold it down for 2 seconds, you change this to 2000. Okay, so you got these 4 rungs right here times 10. You may even want to do 1 set here, make sure you got it working right, and then copy and paste it 9 times. So this is going to take you some time, folks. So pause right here and go and create the configuration for input 0, and then come back and do input 1. Here's input 1. Pause and come back and do input 2. I'm sorry, input 1. So the first one was input 0, input 1, you already did that, and now input 2. The logic's identical, just all of the memory locations are different. So this is input 2, pause and come back. This is input 3, pause and come back. This is input 4, pause and come back. Input 5, pause and come back. Input 6, pause and come back. Input 7, and the pattern for the bits is the same. It's a dead match to all the others, the pattern and the bit use. In other words, B13 7 is for input 7. See, all these are B13 7. Okay, this is for 8, input 8, same 4 rungs. You just have to change all the addresses. This is for 9. Okay, pause and then come back. Okay, you've got all the code now to make this work. So now, and the 1100 the 1100 does support online programming, but the emulator does not. In other words, when they created the emulator, they didn't add the functionality for you to do online editing. So that's unfortunate, but it's not a showstopper. You can still do all your projects. So I'm going to go to main, and you see there's no program here, right? Go back to ladder 2. See, we're set for MicroLogix 1100. So I'm going to save this because I didn't change anything. Okay, and then I'm immediately going to go offline, and then I'm going to do a project. So I'm going to, before I start, I'm going to save as, and then I think I call the first one project 00. Project 00. Okay, so you see up here now it says MicroLogix 1100 project 00. So now if I edit it and save it, I'm not wiping out or overwriting my template. So I'm going to go to ladder 2, well, ladder 3. There's no code in there. I'm going to put in some code. Okay, so I'll put in a rung, true if on, energize output, and I'll make this input 0/0, and I'll make this output 0/0. Then I'll verify it, and then I will save it and download it. Now I don't have to go up here to comms, system comms like I normally tell you to do, simply because, well, we can do that though. The reason I do not have you use the download here is because it automatically is going to download to whatever driver's setting here, and out in the field you may not want that. You want to really point it out. So, okay, now input 0. If I remember right, I deleted the configuration. So if I right click on it, you see it flicker? Now, let's go to setup and let's make that maintained. Okay, now I'll go back to the main. If I right click on this, it comes on and it stays on. Okay, so it's a maintained switch. If I go back, well, let's just save this. Remember now, it's project 0. It's not the template anymore. I'm going to save it. And so it saved it with this rung. I'll go offline. I'm going to take this rung and Control C, Control V, Control V. And I'm going to edit this to be input 1, input 2, output 1, and output 2. Verify it, save it, and download it to the emulator. Go to the run mode. Now I'm going to go into setup, and I'm going to make this, I'm going to make input 1 a normally open, and I'm going to make input 2 a normally close. So I go back to main now, and you see input 2 is on because it's normally closed. So what happens if I toggle it? It goes off and then comes back on by itself in 1 second. Normally open, toggle it, goes on, and then goes off after 1 second. This, toggle it, goes on, and it stays on indefinitely because it's a selector switch, maintained. When I want it off, I toggle it off. What this does is allows me to simulate in a rough way our digital field device simulators that we sell kits and finished boxes that have 4 states for each input: maintained on, maintained off, or normally open or normally closed. And so each input has a selector switch and it has a push button with Form C contacts. If you flip the toggle switch on, then the input goes on, and if you push the push button, it's wired to the normally closed. When you push it, it goes off. Or if you flip the toggle switch down and it's off, then it's wired with a normally open push button, so when you push it, it goes on. So it gives you 4 states. So that's what you have here. And from here, you can go on and do any kind of program that you want. And I may do one more little thing. I know this is taking a long time, so I'm going to stop here and say this is enough for right now. Thank you very much for your patience. The last thing we're going to do is to save this, save as, and I just for grins, well, I'll save it to make sure it's saved. Then I'm going to save it again as, and I'm going to make it, I'm going to change that 1 to a 4. So, whoops. So it says ML14 instead of ML11. Save. And I can leave the emulator running. So I'm going to go open up another instance. Micro, it could be RSLogix 500, micro starter light. Then I'm going to open up, once again I saved it in the wrong place. So I'll open and I'll go up here to desktop. So I'm looking for, there we go, nope, right there, RSLogix 1400 project, okay? I'm going to open that and I'm going to go to the controller properties. When you see it's the 1100, I'm going to change it to a 1400 Series B. Apply, it's going to warn me. Now I'm going to go double check my channel configuration. I want that to be 38.4 and channel 1. I don't want boot P. So 100, 100, 100, 221. And then the subnet mask 255, 255, 255, 0. Apply, okay. Now, see, I don't want to download from here because if I try to, it's going to try to download to the emulator. I don't want to do that. So I go up here, comms, system comms, go to my Ethernet IP driver, and I'm looking for 221. Give it a minute. See, it red X is all the ones it can't find. So there's my 221 download. Okay, I have to give it a new name, so I'll just add an X to it. Okay, there I am in the run mode, but notice that I still have this bit selected. This is not 1100 emulator, it's 1400 real thing. So I want to turn that off, otherwise the code and these two files will just mess up the whole thing. Now I'm going to go to main. There's my 3 rungs, so I'll flip on input 0, input 1, and input 2, maintained. Now I'm going to push the buttons. Now I'm going to flip them all back off, and I'm going to push the buttons again. Normally open button, normally open button, normally open button. So you see I've gone back and forth between the 1100 and the emulator and the 1400 sitting on my bench. So let's say that I work on this in class or at work or something, and I want to save it. I just save it, but I would save it with the name ML11 Project 0 or whatever I named it. That's all there is to it, folks. That's simple. Thank you for watching. Thank you for your patience.